On this part, we are going to talk about inertia, force, mass, weight, resultant force, centripetal force, and centripetal acceleration. Okay, what is inertia now? If you are on a car, here you are inside the car, and the car suddenly started moving forward. Your body now, you will feel that your body moving where? Forward in the direction of the car or backward? You're gonna see and you're gonna feel that your body is moving where? Backward, in the opposite side. Why? Because now your body is trying to resist the movement of the car. So your body will try to remain in its place stationary. Okay, another example. If the car now, if you are on the car, and the car is moving, and suddenly the car braked. Your body now, where it will go? The car was moving, and suddenly it was braked. So your body, you will feel that it moves what? Forward. Okay, and these two examples are two examples of inertia. What is inertia? Inertia is the resistance of a body to the change in its state of motion. How? In this first example, the state of the motion here was stationary. Was what? Stationary. So that means when it was stationary and the car started moving, the object now is trying to resist the movement, to resist the moving of the car. So it's trying to sit in its place. So you feel that your body is trying to go backward in the opposite direction. So this is inertia. And another example here, the object with the car, they were moving. Both of them were moving. When the car was braked, as you see, your body now, so the car stopped, and your body now is trying to resist this change of motion, which is the change of what? Of the movement. So it's trying to keep in its direction, in its movement. So you feel that your body is trying to keep moving forward. So that means it resists the change in its state, which is the change now that it happens suddenly, which is stopping the car. So your body now is trying what? To keep moving. That means to resist this change in its state of motion. So this is what? Inertia. Okay, force. What is force? If I have an object that is here, an object that is stationary here, if I'm pushing this object with a force, I'm pushing it, the object will start what? Moving to the right. When it is moved, it will move generally with what? With a changing velocity. When there is a change in velocity, that means there is acceleration. It will move with what? With acceleration. And this object now, it has mass. So in this case now, to get the acceleration that the object will move with, you have a common formula that it is what? Force equals what? Mass of the object times acceleration. So force equals mass times acceleration. So if, for example, now, if this object moves with acceleration 2 meters per second squared, and the object was 5 kilograms, in this case, what will be the force? So that means to find the force, just you multiply the mass times what? Times the acceleration. Times you're going to multiply 5, which is the mass times acceleration, that is 2. With the same units, you're going to get that it equals what? So the force equals what? 10 Newton. This is now how you find the force when you have what? Mass and acceleration. And what about if you have the force now and you have the mass, but you don't know what's the acceleration? That means the acceleration just going to be what? Force over mass. Anyone, if you want to find this one now, you multiply these two. If you want to find one of these ones, you divide the other one here, or you put it under the force. Okay, if I have now a force that is trying to push this object to the right, and this force is 5 Newton. And there is another force that is trying to move this object to the left, and this one is 7 Newton. Where will the object go? Of course, it will go what? To the left. But if this object now, 5 Newton was right, and 5 Newton was left. So that means if two opposite forces trying to push the object to the opposite sides with the same value, with the same amount, the object will remain stationary in its place at equilibrium. But if one of them, as you see here, is greater, so that means this object now will try to move, will start moving what? Left. With what amount of force it will go? Now, what is the amount of force that it will take this object left? That means it's going to be 2 Newton. Now, if this object, if its mass is 1, if its mass is 1, the mass is what? The mass equals 1 kilogram. What will be the acceleration now of the object? So the acceleration equals what? Force over mass. So that means the acceleration equals 2 Newton over 1 kilogram. So that means it will move in acceleration, which is 2 meters per second what? Square. So that means what is now the force that is responsible for the acceleration here is only the 2 Newton. It's not the 7, it's not the 5. So that means it's only the difference between them. And we call these ones the resultant force. The resultant force. So if you have opposite directions of forces, you put this one as positive and the other side as what? As negative, or the opposite. So that means any two forces in opposite directions, you give one of them positive and one of them negative, then you start adding. You start adding these ones as vectors. As vectors. If you have a force, this one, and a force, this one here, so that means if you want to add these two forces, it will be a new or a third vector. You add it using what? Hyper. Okay, we understand now what is force. And it equals, as we said, force equals mass times what? Times acceleration. But now, if the object is moving towards the ground, an object is falling down or going up, that means it is moving under the effect of what? Of gravity. And gravity, instead of A, we write it G. So in this case, when it comes mass times gravity, this one we call what? Weight. So what is weight? Weight is a type of force. It is force. And it equals mass times gravity. So when we ask people in general in our normal life, what is your weight? Scientifically, this question is not right. The question has to be, what is your mass? Because the mass, it will be what? In its unit, kilograms. So if we are asking a person, what is your mass? And he says, my mass is 65 kilograms. In this case, this one is only what? Mass. What will be his weight? What will be the weight of this person? So weight equals mass times acceleration, which is 65 times gravity. So gravity, it can be 9.8, it can be rounded also to 10. So that means this person, the weight of this person will be around 650 Newton. What does that mean? That means now if this person here is on the ground, that means he is exerting a force to the ground, a force on the ground that equals 650 Newton. Down. Where? Down. Okay, now we'll understand now what is the relationship between mass and weight, and we understand. Okay, if a person, his mass is 65 here on Earth, what will be his mass on the moon? And the moon, his mass will be also what? 65 kilograms. So mass, whether on the Earth or on the moon or on the sea or on any part, that means the mass will not be changed, but the weight will be changed, because the weight is the mass times the acceleration. Okay, now what is normal force? What is normal force? Okay, if I have a surface here, whether it is a table or anything else, and I have here a box. This box now has a mass of 5 kilograms. That means its weight will be around 50 Newton. That means now this is now the weight of this box is what? 50 Newton. And 50 Newton is a force. And this force now we said it is the force that it will be exerted on or towards the surface. Now, the box now is at stationary. That means it doesn't go down. It's at stationary. And when the object as stationary, as we said, the object as stationary, if we have two forces, for example, 5 Newton to the left and 5 Newton to the right, in this case only the object will be what? At equilibrium, and it will not move towards any place. So why this object now is as stationary while it has a force of 50 Newton down? Why? Because now the surface itself will exert by a force, will exert another force called Fn, normal force. It will be opposite to the weight force here in this question and equal to the weight force. So that means now the force of the weight will equal exactly what? The force, which is what? Normal force. Force due to gravity, which is weight now, will equal what? To the force of the normal force that the surface exerts. So in this case now we have two forces. They are with the same amount, 50 Newton, 50 Newton, and they are in opposite directions. Normal force is upward and weight is down. So that means in this case now these two forces, same amount but different directions. So that means they will guide, or they will put this box to be in its place. So what is the F normal now equals? F normal, it equals now when it is horizontal surface, when the surface is like this horizontal force, it equals exactly what? The weight, the amount of weight, which is what? Mass times gravity, normal force. Okay, what about the normal force if the surface is inclined? How? For example, now I have a surface this way. This one now is the surface and it's inclined. And the box is here, exactly. Here now. This is now the object. In this case, where will be the direction of the normal force? Where will be the direction of the normal force? Okay, to put that in your mind, the direction of the normal force is always, it's like a force. It's like imaginary force. It's a force that goes through the surface perpendicularly out towards the box. So that means now this is now the surface, as you see. So the normal force will go like this, perpendicularly to what? To the surface, and it will move like this. So that means this one now will be the normal force direction. Normal force direction. While the weight always downward. So this is the force of what? Of weight. This is the direction of weight, as you see, is what? Downward. Okay, you understand now what is normal force, and we understand what is its direction, and we understand what does it mean, or what is the source of that normal force. Okay, look here now. What will happen if the weight is greater than the normal force? So that means now objects in generous surfaces, for example, this one is a table now. This one is a table. So the table now, when it was manufactured, there was classifications that says, that means what is the amount of load that it can resist. Okay, now if I put a weight here that is greater than the normal force that this table can resist, in this case, the table will be broken and the box will go what? Downward. But it will remain stationary in its place when these two forces are equal. We're going to understand now what is friction force. Okay, if I have a surface here and there is here an object, and now if I want to push this object, if I want to push it to the right, will it go to the right or it will not go? It depends on what? It depends on my force that I'll exert it, which is F, and it will exert on the weight of that box. And it will also depend on the friction between the two surfaces here, type of friction. So if this surface now was too smooth, so that means it will be easy for you to push this box. So that means what is now the friction force? Friction force is the force that is resulted from the contact between two surfaces, okay, and it's always in the opposite side of the force that exerts on that box. So that means now when you are pushing to the right this box, the friction force that is between these two surfaces will try to push or to the box to the left. It not in order not to be moved to the right. In this case now, this one now, which is friction force. If your force now is greater than the friction force, that means the box will move to the right. But if the friction force is greater than your force, that means the box will not move. It will stay in its place. So what makes this friction force greater or smaller? Okay, in order to push this box easily, we try to make the friction force the smallest possible, because this one will be greater than it, so the object will move. So these ones now will try to make we call it coefficient of friction between these two mediums, the smallest possible. So what is friction force now? Friction force now, it equals the coefficient of these two mediums, and it is different from any two mediums like wood and glass or water and whatever is it. So that means when it is two objects or two different objects will result in two different number, which is called what? Coefficient of friction. And this one is by experiments it was set. That means it is now we have classifications. We have a table for the coefficient of friction for two types of materials. So this one's now we call it what? Mu. So that means this mu now is the coefficient of friction times mass times what? Times gravity. So this one now, it equals what? The friction force. So that means it is directly proportional to the type of materials and the mass of the object. So the greater the object, the greater the friction force it will affect. Okay, if I have now an object, and the question is find the friction force. Find the friction force of an object that it has a mass 3 kilograms and gravity when you weight it's going to be around 10 meters per second squared, and the coefficient of friction is, for example, 0.2. In this case, we're going to multiply 0.2, which is this one now, then multiply it by the mass, which is 3 times what? 10. So 3 times 10 is 30. 30 times 0.2 is going to be around 6 Newton. So in this case, now we understand what is the friction force and how can you calculate it and what does it depend on. And you understand normal forces and you understand the resultant force plus mass, weight, and force.